Okay, hello everyone. This is just a quick follow-up video to the lecture that we had earlier today on the Quintic software that you will need to use to analyze your data for the short research article assessment. So first thing that will happen when you open up the software is you will be asked about a license agreement, and just click on accept later. Don't click any other option, otherwise you might end up spending money you don't want to. The first thing we need to do is open our file. So I've put all of the files on Outlook for you. I suggest downloading them one at a time because they are big files, and once you've got them, I mean, if you've got a PC or laptop that's got good memory, then do as you wish, of course. But when we open the software and we've clicked accept later, we are presented with the main tab, as it's aptly called, and we can use this to open our video that we want to look at by just clicking on this yellow folder. That opens a window which is obscured from your view. Apologies, don't know why. I'm just going to click one at random here. Hopefully it's okay. Okay, so here is our video. The first thing you want to do is zoom out, just to make sure that you've got everything in view that you want to see. As long as you can see the force plates here, then everything's okay. So you have this zoom in, zoom out function down at the bottom here. You can also take a photo if you so wish. You've got a memo notepad, and you can play the video on a continuous loop by clicking any of these buttons. You don't really need any of these, but if you want them, they're there. So if we move back up to the top, we have various different play options. If you click on play video, it will play it in real time. If you click on slow 2, the video will play at half the speed. And you get the idea. If slow 4 plays at a quarter of the speed, you get the idea. An eighth of the speed, a 16th of the speed. Just remember that when you hit play, it will always take the video back to the beginning. So if you pause, the pause button is down here, second from the left at the very bottom. If you, and I've made this mistake many a time, if I click play and then pause and think, oh, that's not quite right, I'll just play it again, it goes back to the beginning. So what we need to do is pause, unpause, and you have this tab here on the right of options that you can use to scroll, or you can click to move through the frames by clicking on either of these arrows, and you can see the frame number here. Now this wasn't, I can't quite see, well, it's not the best frame rate, but never mind. Anyway, right, so we know how to play our video. The next thing we want to do is identify specific markers, and I think this is always useful to do regardless of what sort of analysis you're doing. And markers you can think of as events, key events in your motion analysis that you're interested in. So let's say initial contact is our first marker. So we use the arrows here to click through, and not quite. Maybe we zoom in a bit. No, not quite. Click again. Yeah, definitely. So it's quite a, well, most definitely a flat-footed foot strike pattern there. The more frame rate the higher the frame rate, the obviously the more frames you'll have to play with. This video isn't brilliant, but there we go, never mind. We can then look to identify, say, mid-stance. Now, mid-stance when we're walking is the point midway through the stance phase when the hip, the knee, the ankle are all in alignment. But of course you don't get that with running because of this knee flexion here. So when the hip is aligned over the ankle. So looking for a point when the hip marker is aligned with the malleolus marker here. So we can do that by going to shapes and draw vertical line. Select this, we click and hold, drag the marker over the malleolus marker, the lateral malleolus or the ankle marker here. And to be fair, we're almost there. We'll say for the sake of argument with this one that we'll call, just as an example, we'll say that this frame is mid-stance, but really because he's used a flat foot stroke pattern, the sort of initial contact, and because he's got such a small step, they're more or less the same. And then we can look for, let's say, toe off. Oh, I've clicked a bit too far. Apologies. Probably there. So we can get rid of that vertical line, which we don't need anymore, by either clicking on this red arrow, hovering it over the line and double clicking, or we can just click on clear all shapes and it will go. There are other shapes on here you can draw. You can draw a circle if you wish. You can draw a horizontal line, vertical line. You can draw arrows to represent force. It's but we don't need that today, so you can have a play around with it though. Clear all shapes and they're gone. So going back to our markers, we've chosen 3 different events: initial contact, mid-stance kind of, and or initial contact, mid-stance, toe off. There we are. So we'll use initial contact as, is initial contact, I just thought I'd double check, as a point at which to take our measurements from. One thing you can do here though is take advantage of the stopwatch feature. Click on your first marker, click on the stopwatch, and click on your last marker, and you've got contact time, foot contact time, which is a useful measurement. It's something you might want to read up on. You could certainly add this to your report along with your joint kinematics. Something to consider. Anyway, to measure our joint angles, we need to go to the Angles tab here. We have 4 different types of angle that we can draw. We can change the colour of the angles, which is sometimes useful for telling them apart, and also the size, the thickness of them. And it's probably best just to show, give an example. So click on here, let's go for, blue's a bit dark, let's go for a light pinky colour. So our first angle, make it a bit thicker, that we have is a absolute joint, a relative joint angle. And this is when we're measuring an angle that is dependent on the movement of 2 different limb segments. So for example, knee flexion is a great example when running. So we click on this option and then move over the image, click, hold and drag. You then unclick, take your finger off, unclick if that's a thing. Move your cursor to the other marker that you're interested in, click again, and we've got our measurement here. Okay. It will always give you the measurement in degrees on the smallest side, so the side of the least angular displacement. So in this case it's this obtuse angle here, around the other side it would be the reflex angle. However, you can find out both by clicking on display results, and what's nice is it's even colour coded to the colour that you use. So if we now draw another one that's, I don't know, let's go for this horrible vomit green colour that they've got on here. You can draw an angle, and there we are in vomit green. Very nice. More sort of turquoise actually. I take it back, that's not vomit green. And we can choose to get rid of one of our angles if we want by clicking on the red arrow option here, or we can just get rid of them all by clicking clear all angles. So that's our relative joint angle. We then have two absolute joint angles. Just choose a different colour so they stand out. Go with red. The first is based on a fixed vertical line, a line that will always point upwards. So once again, we select this option, click, drag, keep our finger down, so we're clicking, holding and dragging, and there we are. So you will always get a fixed vertical line on that. This absolute joint angle is a fixed absolute, is an absolute joint angle that is fixed to the horizontal. Let's go for, yellow stands out quite well on here, yellow. I'll put this over here. There we are. Click and drag, so select the option, click, drag, let go. Okay. The other option is an intersection angle. I wouldn't necessarily think that you're going to make use of this too much. I would use the previous three that we've shown here. So these are both absolute joint angles. This is relative. So as I said, vertical, horizontal. This will always be to the left. This will always be acting upwards, which isn't a big deal. We can just use a bit of mathematics if we need to get a different measurement. Let's go with this nice pinkish colour, and we will look at this intersection angle. So we click and hold, and we have a line, and then we click and hold, and there we are. It forms a angle. It takes an angular measurement at the intersection that is made between the two lines that you draw. There we are. But that one's a bit fiddly. I can't think that you're going to use that for this project. So for the knee, we go from, I might just zoom in a bit more. You need to be precise here because this is where we get the accuracy from in our data, but also this is where things can obviously go wrong. You need to go from the center of the marker to the center of the other marker. So this is the greater trochanter marker here to the center of the lateral femoral epicondyle marker here. Could be better, but as an example that'll do. And then we'll click on the middle of the lateral malleolus marker, and there we are. That's our joint angle there. And as I said, what this isn't actually the value that we're looking for. The value that we're interested in is here. and I've put on Brightspace the calculations that you need to do in order to find out what this value is, but it's fairly simple. You just subtract this value that you get from 180. So when running, we use a relative joint angle again. So let's go for something that's going to stand out. We'll go with the green again. Maybe make it a bit thicker. I wouldn't suggest having too many angles on the page at the same time because it can get a bit confusing. There we are. And again, there's instructions on Brightspace on how to process this and what to do with it. This is different to the squat, where you would use a absolute joint angle to measure ankle flexion extension. So just something to bear in mind. And for the hip, we use an absolute joint angle. And we'll go for blue. We get knee to hip marker. Oh, I've done a relative joint angle, apologies. There we go. There we are. And again, we're not actually interested in this value per se. What we want to know is what is this angle here? This is hip flexion. When the hip, well, by hip I mean the thigh, so when the greater trochanter and lateral malleolus markers are in alignment here with this fixed vertical line, the thigh is said to be in a neutral position. When it moves to the right, in this instance, we're in flexion. When it moves to the left, we're in extension. But anyway, on the left hand side here of our results tab, which again we get by just clicking on results, wherever it's gone, angles, there we are, display results. These are the values that you're going to want to work with, not these. And the equations are on Brightspace. And that's basically it. Once you've got that, the same is true for the squat videos. If you wish to look at them, I can upload one very quickly just to show you a couple of differences. So here's a example with using the squat, or one of the squat videos. Again, zoom in. This is one I made earlier, as it were, so I've already highlighted some markers. You can just about see there's a very subtle difference. It's very consistent though in his movement pattern. I've highlighted the first 3 points of peak flexion. Hip flexion, knee flexion are measured exactly the same as with the running video, or the running gait files that I showed you a minute ago. We can also look at trunk flexion by using an absolute vertical angle, going from the acromion process on the top there to the greater trochanter. And this is the only one of your measurements that you could take that doesn't need any further processing. That is trunk flexion. Done. Or I should say, to be more specific, forward lean would be more specific. I suppose if you were to look at trunk flexion, you'd need to look at in greater detail and have more markers down the spine. But forward lean, let's call it. So that's nice and straightforward. You just need to select a vertical angle. the only other angle that is different is the dorsiflexion angle. Now this is made somewhat more difficult because these guys didn't shut the curtains when they made this video, so it's going to be a bit tricky to see where these markers are. But ankle flexion is the only other value that is different. I can see one marker there and I can see one there, so going from there to there. So again, there is the mathematics on Brightspace that I've put to show you how to calculate what you need with this angular information here. And we use a absolute joint angle with the squat as opposed to a relative joint angle when we're running, because dorsiflexion is dependent on movement of the tibia on a fixed foot. The foot isn't moving anywhere. There's a slight bit of movement there, but it's not going to affect the dorsiflexion at all. It's all based on the movement of the tibia. You see that again. So we call this closed kinetic. Oh, there's Adam. Closed kinetic chain dorsiflexion as opposed to open kinetic chain dorsiflexion. So we measure it in a slightly different way. So there we go. Just a brief overview what you need to do. And I hope that's helpful.